Earth Systems 3209. Unit 3, Earth's Materials. References can be found in the textbook in Chapters 2, 3, 6, 7, Appendix A and Appendix B from the Curriculum Guide. Unit 3, Topic 3.3. Here we will discuss the classification of igneous rocks, and our focus will be on texture. This presentation will focus on explaining the relationships between geologic environment, rate of cooling, and texture. Focus on identifying 5 common igneous rock textures. And a focus will be on explaining how the different igneous rocks can have the same texture. When we look at classifying igneous rocks can be classified according to 2 characteristics. The first characteristic, which will be the focus of this presentation, is texture. Texture describes the appearance of the igneous rock based on the size, shape, arrangement of the interlocking crystals. Igneous rocks can also be classified according to mineral composition, that is, the mineral makeup of the igneous rock based on the chemical composition of the parent magma. References in the text can be found on pages 61 through 75. When we look at texture, texture refers to the size of crystals, the general shape of the crystals, and how the crystals are arranged. When we look at size, shape, and arrangement of the interlocking crystals, we can see different types of texture in igneous rocks. The texture of an igneous rock can reveal a great deal about the environment in which it cooled and solidified. Crystal size is the most important factor when we look at texture, and the size of the crystals are determined by the rate at which the molten rock cools. If the molten rock cools beneath the surface, it tends to cool slowly, creating bigger crystals. And if the molten rock cools at the surface, then it tends to cool quicker and it has smaller crystals. So cooling rate is probably the single most important factor when it looks at igneous rock texture. Molten rock, namely magma, can cool beneath Earth's surface in a plutonic environment. Large crystals form deep within the Earth, where the magmas take up to tens of thousands of years to cool and crystallize. Therefore, the slower cooling of the magma results in larger crystals being formed. These larger crystals form what we call a coarse texture. And some examples of rocks that form in an igneous environment will be gabbro, diorite, and granite. All 3 of these rocks have a plutonic, igneous, coarse texture. Even though the 3 different rocks are made up of different compositions, they have the same texture. So if you look at the diagram to the right, we look at magma, which is located beneath the Earth's surface. It tends to cool slowly. As it cools slowly over thousands and tens of thousands of years, the crystals can grow larger and larger. These crystals will form what's called a coarse texture because of a very slow cooling rate. Also, when we look at the cooling rate in a volcanic environment, molten rock called lava can cool on the Earth's surface. The fine crystals which form on or near the Earth's surface where lava cools quickly, it can cool in a matter of minutes to hours. Therefore, the quicker the lava cools, the smaller the crystals. We call this a fine texture. Some examples of igneous rocks which exhibit fine texture will be basalt, andesite, and rhyolite. And these 3 rocks form in an extrusive or volcanic environment. If we look at the diagram to the right, we see lava, which is located on the Earth's surface. It cools quickly, therefore the crystals cannot grow as big, and we end up with what's called a fine texture. So again, basalt, andesite, and rhyolite are all three igneous textures that have fine texture, and these three rocks would have a different mineral composition. So in conclusion, the cooling rate is directly related to crystal size. If the cooling rate is slow, we tend to have larger crystals. If the cooling rate is fast, then we tend to have smaller crystals. Slow cooling rate is found in a plutonic environment, and a fast cooling rate is predominant in a volcanic environment that's found at the Earth's surface. Let's go and look at 5 of the different igneous rock textures that exist. The first texture is what's called a coarse grain texture. Coarse grain textures form deep beneath the surface in plutonic environments where the molten rock cools slowly. In this case, the molten rock would be called magma. We generally see larger crystals with uniform size. This texture can also be called a phaneritic texture. That's the geologic name put on coarse texture. Minerals can be identified with the unaided eye. The examples of coarse grain textures include granite, which make up the continental crust, gabbro, found beneath the ocean crust, and diorite is generally found deep within mountain chains. If we look at the diagram to the right, we see an example of granite. And here we can see fairly uniform, equal dimensional crystals of quartz, the pink feldspar, and the darker would probably be amphibole or even biotite mica. So in conclusion, a coarse-grained igneous texture would form deep beneath the Earth's surface by slow cooling of magma, which forms larger uniform crystal sizes. The second texture we can look at is called a fine-grained texture. Fine-grained textures form at or near Earth's surface in volcanic environments, where the molten rock, namely lava, cools very quickly. We generally see very small crystals, which you cannot identify with the unaided eye. You generally need a microscope to see these crystals. They may contain vesicles or gas bubbles within its texture, and it's also called aphanitic texture. This would be the geologic name for the fine-grained texture. And common minerals are not identified with the unaided eye, and the rock appears to be one uniform color, as you see here to the right. Some examples of fine-grained textures include basalt, andesite, and rhyolite. The diagram to the right would give you an example of a basalt, where we generally see dark-colored minerals, and they're fairly fine-grained. Therefore, you cannot identify them with the unaided eye. So the 3 fine-grained textured igneous rocks, basalt, andesite, and rhyolite, would consist of the same texture, but are made up of 3 different compositions. The third type of texture, which is seen in igneous rocks, is called porphyry texture. This texture results when magma with crystals already formed escape to the surface and cools quickly, forming a fine-grained igneous rock with large crystals inside. This texture is a result of 2 stages of cooling. First, we have slow cooling beneath the Earth's surface in a plutonic environment, which forms the larger crystals that we see in the rock here. The larger gray crystals would form deep within the Earth in magmas that are cooling slowly, which give those crystals time to grow. And then all of a sudden, the magma erupts to the surface, and at the surface we see rapid cooling, which forms the finer crystals that surrounds the larger crystals. In this case, this is called an andesite porphyry. We tend to see a mixture of color between dark and light, which forms an intermediate composition rock. But the porphyry texture, as outlined in this diagram or in this rock sample to the right, will show larger crystals which form by slow cooling of magma beneath the surface, and then suddenly the magma erupted and moved to the Earth's surface, where it cooled quickly and formed fine-grained rock which surrounds all of the phenocryst, or the larger crystals. So the key point to a porphyry texture is you would need to mention it includes 2 stages of cooling: slow cooling beneath the surface, forming large crystals, and fast cooling when it erupts to the surface, forming the fine crystals. A fourth type of igneous texture is called glassy texture. Glassy texture forms when the ions of molten rock do not have any time to organize into an orderly pattern to form crystals, because the magma or lava, when it erupts to the surface, it will cool very, very, very quickly. It almost cools instantly when it comes in contact with a very cold surface, such as ice, snow, or ocean water. Therefore, the crystals don't have any time to grow, and what will result is something called volcanic glass, as we can see here to the right. Minerals cannot be identified with the unaided eye because no minerals had time to form. Therefore, this rock is called obsidian, and obsidian is volcanic glass. The fifth volcanic igneous texture would be called a vesicular texture. A vesicular texture forms when gas bubbles escape from molten rock and are trapped as it cools and crystallizes. This texture can be formed near the top of lava flows, and minerals cannot be identified with the unaided eye. An example of this type of texture would be scoria if it was a mafic magma, and also pumice would form if it's a felsic magma. In both cases, we see vesicles, which are air bubbles that escape from the magma, and as the rock cools at the surface, the lava will form this frothy rock on the top of the lava, which would have a vesicular texture, and is primarily due to the gas bubbles escaping from the lava, where it gets trapped into a froth-like rock that forms on top of the lava. So this will be called a vesicular texture. Let's have a look at some of the different textures seen in common igneous rocks. The first rock will be a fine-grained texture, where we cannot see any evidence of crystals. In the second picture to the right, we see a coarse-grained texture, where we can identify the different crystals and the different minerals that are present. The third picture, we see big crystals which formed in a plutonic environment, and then that's surrounded by a finer matrix which forms the rest of the rock, and that would have formed at the Earth's surface in a volcanic environment. And fourth, we see volcanic glass, which is a result of lava or molten rock coming in contact with a very cold surface and being quenched instantly, not giving any crystals any time to form, which results in a glass texture. If we look at the igneous classification chart according to texture, we see that we can have a coarse-grained rock, fine-grained rock, vesicular rock, and a glassy rock. These four textures are very common in igneous environments. We can also have a porphyry texture, which is not described here in this chart. Coarse-grained igneous textures tend to form in plutonic environments. That would be beneath the Earth's surface. There are three different compositions that form beneath the Earth's surface. A felsic composition would form granite, intermediate composition would form diorite, and a mafic composition would form gabbro. So in this case, three of these igneous rocks, granite, diorite, and gabbro, form beneath the Earth's surface in a plutonic environment and would have the same coarse grain texture, but they consist of three different compositions. If we look at fine grain textures, we also have three equivalents. We have rhyolite, andesite, and basalt. All three of these rocks would form in a volcanic environment and would have a fine grain texture, even though they have different mineral compositions. Vesicular, if we look at felsic igneous rock, the felsic equivalent to a vesicular texture would be pumice. That would form a frothy covering on a felsic lava, which is generally light in color. And we also can have scoria, which is the equivalent to pumice, but it forms on a mafic magma or a mafic lava once it erupts to the surface. So pumice is a vesicular texture found in felsic igneous rocks, and scoria would be a vesicular texture found in mafic igneous rocks. And the last would be the glassy texture, which would be obsidian, which is compact glass when a felsic igneous rock comes in contact with snow, ice, or cold water, and the felsic composition of lava would cool instantly, forming obsidian. We can also look at the question, what are the similarities and differences between the following rocks? So if we look at the rocks that are coarse grain in texture, gabbro, diorite, and granite all have the similar texture. They're coarse grain. They all form in the same environment, which is plutonic, and this is found in an intrusive environment beneath the Earth's surface. The difference between these three rocks is they all have different composition, therefore they're made up of different minerals. If we look at the volcanic environment, we see fine grain rocks such as basalt, andesite, and rhyolite. All three of these rocks have similar texture. They have a fine grain texture. They all are volcanic, where they form in an extrusive environment on the Earth's surface. And the difference between these rocks, again, would be composition. They are all made up of different minerals, but they have similar textures. Let's look at some examples. Example number 1 reads, which rock forming process will result in a glassy texture? So a glassy texture is very significant of an environment which cools very, very, very quickly. Our choices, the alignment of minerals as a result of stress, that wouldn't be appropriate. Cementing together of large angular crystals, that wouldn't be appropriate answer for this question. And C is the rapid cooling of lava at Earth's surface. So that would be the best answer to answer this question. So glassy texture results from a rapid cooling of lava at the Earth's surface. Example number 2 reads, an igneous rock is found to contain both large and small crystals, as shown below. What conditions were necessary for this rock to form? So if we look at an igneous rock that has large crystals surrounded by a fine crystal matrix, we know that this rock had formed by two different stages of cooling. Slow cooling forming the large crystals, and rapid cooling forming the small crystals. So as a result, we could say that this texture was a result of two stages of cooling. Slow cooling, which formed the large crystals beneath the Earth's surface, followed by eruption, where the magma carrying the crystals went to the surface, and it rapidly cooled, forming the finer crystals that make up the remaining matrix of rock. Your turn. Take the time and complete the following question. The solution to this question will follow on the next slide, so you can stop your recording now to prepare your answer. Let's look at the answer to the following question. The question reads, describe two things that can be determined by examining the crystal size of minerals in igneous rocks. So by reading the question carefully, we're looking for two things that can be determined by examining the crystal size. So what does crystal size tell us about the igneous rock? When we look at the solution, we can see that crystal size of minerals in igneous rocks can indicate two things. The first thing that crystal size will indicate is the environment in which the molten rock cooled. If it is big crystals, it formed in an intrusive or plutonic environment. If it has smaller crystals, then it formed in an extrusive or volcanic environment. So the environment is indicative of the crystal size. The second thing that can be determined by crystal size is the cooling rate of the molten rock. If the rock has large crystals, we can conclude that the magma cooled very slowly in order to give the crystals time to grow. If the igneous rock has small crystals, then we can conclude that the igneous rock formed in a volcanic environment where the lava cooled at a fast rate, giving it small crystal size. So two things that can be determined by crystal size would be the environment in which the molten rock cooled and the rate at which the molten rock cooled. In summary, let's have an overlook at the points we covered. Texture is controlled by the number one determining factor, that is cooling rate. So cooling rate determines the texture seen in igneous rocks. The cooling rate itself will be also indicative of the environment in which the molten rock cooled. So if we look at fine-grained rocks, fine-grained rocks cool fast. They form at or near to your surface in a volcanic or extrusive environment, and we can't generally see the crystals in fine-grained rocks. In comparison, coarse-grained rocks, they form by slow cooling magma. They form beneath the Earth's surface in what's called a plutonic or intrusive environment, and we can see visible large crystals in the rock. If we look at a porphyritic texture, porphyritic texture forms when magma cools beneath the surface, forming large crystals, which is then erupted to the surface where it cools quickly and forms small crystals. So porphyritic texture would go through two stages of cooling. And last, glassy texture would cool very rapidly at the surface when the molten rock comes in contact with a very cold surface such as snow, ice, or ocean water, and the ions do not have the ability to organize themselves into a crystalline structure to form crystals. Therefore, it results in a glass. And the example of a rock with a glassy texture would be obsidian. We also have a vesicular texture, which is not described here. Vesicular texture would form when lava comes to the surface and the gas bubbles escape from the lava